Hi guys, Dr. Kruse here. Algebra video about solving for x, or solving for p, or solving for c, or solving for any letter you like. And then once we solve that equation, I'll show you how to put it into a graphing calculator and go to the table and tell me when things are going to happen. So let's start by solving these two equations up here, and I notice they both have x's on both sides of the equal sign. All right, so keep the equal sign in sight. All right, this breaks your equation into the left side and the right side. Now, the first thing you want to notice is that we have x's on both sides of the equal sign. So I need to gather those x's on one side or the other. I can either bring the 9x's over here to the left side, or I can bring the 7x's over here to the right side. It doesn't matter, it's just whatever you want to do. I chose to move the 9x's over here. So what I did is, since that's a positive 9x, I minus 9x. You can write that in here if you want to. I minus 9x and minus 9x. 7x minus 9x is negative 2x. The plus 3 comes down. This is now gone, and the minus 14 comes down. Don't forget the minus. All right. So now it's, instead of minus 14, it's negative 14, but it basically means the same thing. Next thing I want to do over here, now that I've got the x's on the left side of the equal sign, I need to get rid of the negative 2 and I need to get rid of the 3. I usually get rid of the 3 first. It's easier. The last thing I want to do is divide this negative 2 away from the x. So I'm going to get rid of the 3 first. I'm going to minus 3. You can write that in if you want to. Minus 3, and write a new equation. Negative 14 minus 3 is now negative 17. The 3 is gone, and the negative 2x comes down. And then my last step is to get this x alone on that side of the equation. The last step is, since this is x times a number, then we're just going to divide by that number. Now remember, the number is negative, so I want to divide by negative 2. I want both the 2 and the negative sign to cancel out. So divide both sides by negative 2. The negative 2 is gone, the x comes down, and my equation now says x equals, this simplifies to the fraction positive 17 over 2. A negative divided by a negative is a positive, or you can change it to the decimal 8.5. I just want you to note the last step is dividing that number away from the x. That's always the last step in these equations. If we look at this one over here, different equation, but this time I chose to move the x's to the right. Doesn't matter if you move the 9x's over to the left or if I move the negative x over to the right. It's whatever you think is easier. So here's my equal sign. Here's the left side. Here's the right side. I chose to move this x over to the right side. To make this go away, I plus x. All right, this x is gone now. 5 comes down. Over here I have 19 plus x plus that x that I just added. X plus x means I have 2 x's. So now instead of 19 plus 1x, I have 19 plus 2 x's. You guys can write in plus x if you want to. My new equation says 5 equals 19 plus 2x. Remember, the last thing we do is divide that 2 away from the x. So don't look at that right now. Let's get rid of the positive 19. So think plus 19. To get rid of it, you minus 19 minus 19. 5 minus 19 is negative 14. 19 is gone. 2x comes down. That's my new equation. Negative 14 equals 2x. And now the last step is divide this number away from the x. So I'm going to divide by 2, divide by 2. The 2 is gone. The x comes down. And my final equation is x equals negative 7. Now let's take away all the numbers. This is what freaks people out a lot. If I take away the numbers and just give you letters, I can say something like, to find r, all you need to do is multiply c times p, whatever those letters stand for. So this has been solved for r equals cp. Whatever letter is alone is what you solved the equation for. Up here we solved for x, and over here we solved for x. Well, now we're just solving for a different letter. We were given an equation that solved for r, and they asked us to instead solve for p. So instead of the r being alone, I want the p to be alone. So if I'm given the equation r equals cp, to get the p alone, I just need to divide the c away from it. So divide by c, this c is gone, p comes down, and my new equation says P equals R divided by C. So all I've done is just rearrange the original equation, and now instead of saying to find R, you multiply C times P, well, to find P, you take R and divide it by C. All right, now the only one we haven't solved for is C, so same equation. It started out saying R equals CP, and then we changed it to P equals RC. So I solved for R. I was given an equation that solved for R. I juggled it so it solved for P. And now let's start with the original equation. Let's solve for C. So if I'm solving for C, I just need to get rid of that P. I need to divide the P away from the C. So divide by P, divide by P. This P is gone. C is R divided by P. R divided by P, excuse me. So three equations. The original was solved for R. To find R, all you do is multiply C times P. To find P, all you do is take the R and divide it by C. To find C, all you do is take the R and divide it by P. Now this will make more sense if you pretend you're an electrician. Electricians, they deal with volts, amps, and resistance, and there's a relationship that says the volts can be calculated by multiplying the amps times the resistance. I don't know why they use capital I for amps, but they do. So given that volts, to find volts, all you do is multiply amps times resistance. That's solved for V. Well, maybe you want to calculate amps instead. Maybe you want to solve for I. So start with your original equation. You want to divide the R away from the I. So divide by R, write a new equation. I is alone. You solved for I. And so you're saying to find I, all you have to do is take the volts and divide by the resistance. To find the amps, all you do is take the volts divided by the resistance. All right, let's start over again. V equals IR. This time let's solve for R. To get the R alone, I just have to divide the I away from the R. So divide by I, write you a new equation. I is gone, R comes down. V over I comes down. I'm just going to rewrite it and put the R here and the V over I over here. So R, resistance, can be found by taking the voltage divided by the amps. Okay, sometimes we see some kind of strange problems with nothing but letters in them. I'm going to help you through a couple of these weird ones. Maybe I have A. To find A, all you do is multiply C times B, and then multiply D times B and add that to it, and then subtract E. All right, whatever they're talking about here, maybe this is how you find A. This has been solved for A. Well, just like the electricity question, maybe I want to solve for C instead. Well, look where C is. I've underlined it. So I have all of these letters to get rid of. Well, it's not as bad as you think. All right, I'm going to start down here at the end. Whenever I see a bunch of pluses and minuses and stuff, I usually start at the end and just work my way back to the letter I'm trying to get alone. So the first thing I'm going to eliminate is minus E. So to get rid of minus anything, you add that thing. So I'm going to plus E to both sides of my equal sign. So bring your equal sign down and write a new equation. So on the left side, I have A plus E. We're just going to write it like this because I can't put them in the calculator or anything. They're not like terms. I can't put them together. All I can do is just write it out. A plus E. CB came down, DB came down, and the E is gone. So A plus E equals CB plus DB. Okay, next, working from the end, back to the C. I'm working from the end. I'm going to get rid of this number here. D times B, I don't know what that is, but if they told me what those two numbers are, I could multiply them together, and it's just going to be plus some number. All right, so just think of that as one number. To get rid of plus any number, you just minus that number. So I'm going to minus this number, dB, both sides. I'm going to bring my equal sign down. I'm going to write a new equation. So on the left, I have A plus E minus dB equals CB. All right, A plus E minus dB equals CB. The dB's one away from the right. Now the last thing I want to do to get this C alone, the last thing I want to do is divide that B away from the C. So I'm going to divide the right side by B, and over here I have to make sure I divide the entire left side by B. I'm going to write a nice final equation. So bring my equal sign down. My C is alone. And C equals, to find C, what you do is you take A plus E minus DB and divide it all by B. All right, moving over here, what if you see that to find A, all you do is B times C times D times E? And maybe they want to solve for B instead. Right now it's been solved for A. Well, I like to think of this, all right, when you have a number times a number times a number, I like to think of that as just one number. For example, maybe C is 2 and D is 3 and E is 4. Well, what's 2 times 3 times 4? That's just 24. So I could think of this as B times 24. Well, if it were B times 24, then to get rid of times 24, I would divide by 24. So whatever they're multiplying B by, I'm just going to do it in one step. I'm going to consider this one number, just like 2 times 3 times 4 is 24. I'm just going to consider this one number and just divide it all off at once. So I'm going to divide the right side by this number, CDE, and I'm going to divide the left side by that same number. Write you a new equation. The B is alone. We isolated B. We solved for B. And to find B, all you do is take A and divide it by the product of CDE. All right, now that we know how to isolate a variable, we can put that equation into the calculator and we can go look at the table and we can answer some questions. So for example, you have an inventory of 4,800 sweaters. That's your initial value. You start with 4,800 sweaters and you're selling, or you're getting rid of 600 sweaters each week. Well, first step, let's write a formula, something that we can put into our calculator. I'm going to use S for number of sweaters and W for weeks. So the number of sweaters, S, depends on how much time has gone by, W. So S in terms of W, S of W. So S of W is going to equal what we started with, and then minus, because we're selling, this number is getting lower, what we started with minus 600 each week, W. So our equation is going to look like this down here. The number of sweaters in terms of how many weeks have gone by is what you started with, 4,800 minus 600 each week. All right, the number of sweaters depends on what week it is, or how many weeks have gone by. Once you plug this into your calculator, you can come up with this table right here, and I'll show you that. All right. All right, I got the good old TI-83 here, and I pressed my Y equals button. I'm going to put in Y equals what I started with minus how fast it's going down, 600 each week. We have to use X in the graphing calculators. So Y equals, press your Y equals button, started with 4,800, that's called your initial value, and then it's decreasing at a rate of 600 each week. Well, now that I have this in the calculator, I can graph it right here, or I can look at the table. I want to look at the table because I'm going to ask you when we run out of sweaters here in a minute. Before I look at the table, let's go into table setup right there above window, and let's set up our table so that we just start at 0 and go up by ones. So table start, I want to start at 0, and then delta table, that just means how fast you want to increase your x's. I just want to go up by 1. We could go up by 2s or 3s or whatever. I just want a normal table that starts at 0 and goes up by 1s. So now I'm ready to look at my table here. So second function, table, and there's my table. So at 0 weeks, I had 4,800 sweaters. That's my initial value. That's what I started with. Back in junior high, you called this a y-intercept. All right, I started with 4,800 sweaters, and every time a week goes by, X is your time, I have 600 less sweaters, or 600 fewer sweaters. And after 2 weeks, I have 3,600 and so on. So my first question is, hey, when do you run out of sweaters? All right, so how long before you run out of sweaters? Now, if I ask you when or how long, I'm asking for the X. I'm asking for the time variable. And then out of sweaters, they didn't actually give you a number, but when you're out of something, that number is 0. So we're wondering when the number of sweaters is 0. When is Y 0? It's pretty easy to answer on this problem here. We just scroll down and watch the number of sweaters, And right there, after 8 weeks, I am out of sweaters. Now the table goes further, but those numbers don't make sense to this problem because when you're out, you're out. All right, so we are out of sweaters after 8 weeks. But I want to do one more word problem with you. The resale value of a boat depends on how much time has gone by. All right, a boat's like anything else, like a car or truck or anything. The value is going to go down, the older it gets, the more time that goes by. And in this problem, they told us to use V for value, and it depends on T, how much time has gone by. They said let V measure value in thousands of years. So this is important because on the calculator, if we see the number, say 2, it stands for 2,000. Or if we see the number 5, it stands for 5,000, and so on. So you have to be able to interpret your table and know what it's telling you. And T, sometimes T is the number of years that have gone by, sometimes T is the actual year. In this case, they said let T be the years since 2011. So it sounds like this guy bought this boat in 2011, and we're trying to calculate what it's worth as time goes by since 2011. All right, so our X value is actually going to be the number of years since 2011. All right, given this equation, we're just giving you the value of the boat with respect to how many years have gone by is what you started with, 12.5. Remember, we're speaking in thousands of dollars, so that's technically $12,500. So your boat started out being worth $12,500, but it's decreasing. It's worth less each year. This is how fast it's decreasing. Remember, we're speaking in thousands of dollars. That's 1,300. So it's decreasing at a rate of $1,300 each year. Now they said calculate the value of the boat 4 years later. Well, let's put this in our calculator and do that. All right, I have my equation in here. The value of the boat is $12.5 thousand minus $1.3 thousand each year that goes by. I'm getting ready to look at my table, but I want to set it up first. Let's just make it start back at 0 and go up by ones. That looks good. And let's go to our table and see what's what. They asked us the value after 4 years have gone by. So the initial value is 12.5 thousand. 1 year later, it was worth 11,200. 2 years later, it's worth 9.9, and 3 years later, it's worth 8.6, and 4 years later, there's what we're looking for. The value of the boat 4 years later is 7.3. Now remember, we're speaking in thousands, so that answer is $7,300. So after 4 years of owning the boat, it's only worth $7,300. Another question is, in what year will the value be $4.7 thousand? Look at your clue words, all right? Use your context clues. In what year? That's a when question. They're saying when will the value be 4.7? So they're asking for X and they're giving you Y. All right, so I need to know when the value is 4.7. There we go, right there. The value is 4.7 after 6 years. Now the question was, what year is that? After 6 years. In what year? Well, the years are the years since 2011. So 6 years later is going to be 2017. So in 2017, the boat will be worth $4,700. In what year will the resale value be $3.4 thousand? All right, go look for that value. There it is in year 7. And what year is year 7? 7 years since 2011 is the year 2018. So in 2018, the boat will be worth $3,400. All right, guys, that's all I got for you.